Course 3, Lesson 115. We are looking at the relative sides and angles of our triangles. So our goal is to be able to list angle measurements from least to greatest and be able to list our side lengths from least to greatest without a lot of information being given. So, for example, if I were to take this triangle and say list the angles from smallest to largest, well, when we look at this, we would say, you know what, that C, it looks like about a 90-degree angle, and the angle B looks quite a bit bigger than angle A. So I would list these and say I have angle A being my smallest, angle B being my middle, and angle C being my largest. And list the sides from smallest to largest. Well, it looks visually like BC is the smallest, CA is the middle one, and BA is the hypotenuse, therefore the largest one. The big thing to note here, and this is really the whole point of this lesson, is that if I look at this angle A and I look at BC, well, what you start noticing is that this smallest angle is across from the smallest side, okay? And then if we look at angle B and side CA, the middle angle is across from the middle side. And lastly, our biggest angle is across from the biggest side. Oftentimes we use this relationship to even name the sides specific ways by saying if I have angle A, then the side across from it is side A. Or angle B across from it is side B. Angle C across from it is side C. Without really knowing anything about this triangle, we can make quite a few assumptions about the biggest and smallest angles and sides. So let's look at this one. We don't have a ton of information. We can add the other angle since I know that a triangle adds up to 180. R is 59 degrees, Q is 61, so P must be 60 degrees. So if I list the angles from smallest to largest, I have angle R, angle P, and angle Q. From here, I can actually list the sides from smallest to largest, and I don't actually have to assume anything now since I know this relationship between our angles and my sides. So let's name the sides here based on the angles. 59 degrees is across from this side here, so angle R relates to side R, or we could also call it PQ. And then our middle one, this 60 degrees is across from this side over here, so we would name it side P. And then 61 degrees is across from this side here, so side Q. So depending on how you label them, we would say smallest to largest is side R, side P, side Q, or using the vertices there, we have PQ, we have RQ, and we have RP. Okay? All right, let's keep going with this. Just a few more examples. This is just a quick lesson about this relationship. Okay, list the angles from smallest to largest. Well, this relationship goes back and forth. If I have the longest side, it would be across from the largest angle. And smallest side would be across from the smallest angle. So if I see the smallest side of 7, then that side is across from the smallest angle. So angle C is my smallest, and then 8 is across from this B angle, so angle B is next. 9 is across from angle A, so angle A must be my greatest. I don't know what the angle measurements are, but I can assume smallest to largest. And then we can also talk about those sides. So AB is the smallest, AC is the middle, and CB is the largest. Okay, if we know the length of one side, how could we find the length of WY? Well, let's look at these triangles and just fill them in with all of the angle measurements that I would know. Well, I know this adds up to 180, so if I take 40 and 85, that gives me 125, so I must have 55 degrees left for this angle A. And then in our other triangle, 55 and 85 add up to 140, so I must have 40 degrees left for this angle y. Well, what we notice from these two triangles is that they are similar. We have same angles, so by angle, angle, angle similarity, I can say that these two triangles are similar. So triangle ABC is similar to triangle WYX. From this, we can say a lot. We can actually learn a lot. Find WY if AC is 6. So if AC right here is 6 centimeters, well, the relationship between AC and WX is similar. It's in proportion. And in this case, 6 centimeters equals 6 centimeters. So we actually have congruent triangles here, even though it doesn't look like it. That's okay. So what are our missing sides? Well, the only one that we can find here that we want is WY, and that relates to this AB right here, so it must be 8 centimeters. Okay? We can't figure out right now what BC and YX is without additional information. All right. And I believe this is our one of our last problems. All right. So find the measure of angle CBD, angle DBA, and angle DAB. Remember that if we have more than one triangle fit together, we need to make sure to name these angles with 3 different parts so that we know exactly what we're talking about. Well, I know a lot about this shape. I know that angle C is 90 degrees. And if I have that, then this triangle DBC has 90, 60, and therefore this one has to be 30. So DBC, or you can call it like up here, CBD, has an angle measurement of 30 degrees. From there, I can also make assumptions about this angle. Since this side is 90 degrees, this side has to be 90 degrees since we have a straight line here. So 30 and 60 degrees add up to 90 degrees. So this angle here of DBA is 60 degrees. And lastly, we want angle DAB, which is right here. Well, I have 60 degrees, 62 degrees, which add up to 122 degrees. If I have 180 total, then I would have, well, 58 degrees left for that angle DAB. So we'll say 58 degrees for that one. So arrange the segments in order from shortest to longest. Well, once again, based on their, within their triangles, what is the smallest and largest? Well, we can say a lot. Okay, so we're looking at all these different segments, and let me just clean up a few things here. So we are looking for AB, we are looking at AD and BD, okay? And then BC and DC. Okay, so we're looking at all of those different segments here. Well, let's look at this first triangle within here. If I look at AB, AD, and BD and compare them, I can see that 58 degrees is going to be my longest side. So that side that's across from it is DB. Or BD, whichever way you want to say it. So that one is going to be the shortest within that triangle. So BD. Okay, that's the shortest there. And then if I look at the 60 degrees, across from it is AD. So that's the next longest within that triangle, AD. And then after that, 62 is the longest after that, so AB. Now, once I compare those with this next triangle, I say that this 90 degrees is across from BD. So that's actually the longest one within that triangle. So if I compare BD to BC or CD, that is the longest one. So I'm actually going to say the other two are shorter than that. The next, the shortest compared to those two is across from 30 degrees. So DC is overall shortest. And after that, across from 60 degrees, BC is shortest from there. So within this triangle, we have shortest is going to be DC, then BC, and then this middle hypotenuse. But that's the smallest of that triangle, which next we would have AD, and then the largest of that triangle, and overall is AB. So we can use a lot of information, or a small amount of information, to get a lot of information about these triangles. All right, and then this is our last one. Which angle in the triangle WXY is the smallest? How do you know? Well, if I look at these different measurements, 0.2 meters, 0.21 meters, and 0.19 meters, all of the angles look similar, but I actually know that since this 0.19 is the smallest side, it has to be across from the smallest angle. So angle Y must be the smallest angle. And then the middle angle would be angle X, since it's across from the middle side. And W is my largest angle from across from the largest side. So hopefully this relationship makes a little bit more sense, and you can find lots of information about these triangles with this relationship of sides and angles. I hope this video helps with your homework and for studying.